Okay, so now we're just looking at some mixed practice with derivatives, and we're going to have to remember all of the stuff we've already learned about derivatives, plus all the new rules we learned today. And of course today, if you need to refer back to this list from the first page of notes, go ahead and do that. You do eventually need to know them off the top of your head. Okay, so with this first one, 5 cosine x, this one is actually a lot easier than it looks. The 5 shouldn't bother us at all. It's a constant multiple. So that just means our derivative is going to start with 5 times whatever the next piece of the derivative is. Now, the derivative of cosine is negative sine of x. So we could write that like this. This is my least favorite way to write this answer. It's technically not wrong right now, but the difference between this and a wrong answer is this one teeny tiny dot that you are trusting my bad eyesight to see. Okay? So if you want to say that you're doing this times a negative sine of x, I would really strongly recommend that instead of just using a dot like that, you use parentheses to really confirm that you're multiplying. An even better way to write this would be to just attach the negative right to the 5. So negative 5 sine of x. Okay, second one, I'm going to need to use product rule because I've got something times something, so that's got to be a product rule. This is u, this is v, u prime, and again, you might need to look this up from the previous notes, but derivative of secant is secant times tangent, v prime, x squared, the derivative would be 2x. So I have u, v, u prime, v prime. Product rule, I'm doing, I guess let me write this up here. Product is u prime v plus v prime u. So I'm going to say for my derivative that I have u prime times v, which is x squared, plus v prime, 2x, times u, which is secant x. And that's it. That's my answer. I mean, there's maybe some things we could do to clean it up a little. You probably would normally see this x squared out in front just because usually powers of x go in front of anything else that you've got there, but not the end of the world to leave it this way. This looks great. Okay, so on the next one, I have subtraction here, which means I can do this derivative and this derivative separately, but this derivative is going to require product rule. Okay? To make up for the fact that that one's tricky, the 3 is going to be really easy. This derivative is just a 0. So I'm going to write it in here so you understand like where it came from, but I don't really need to write that 0. I can just pretend the 3 doesn't exist. When I do my product rule, this minus sign, it's going to be easiest if you just attach it directly to the x cubed and have this be your u and this be your v. So u prime, v prime. Derivative of negative x cubed, I was saying the answer already, would be negative 3x squared. And derivative of tangent is secant squared of x. So I'm going to say my derivative, u prime, is negative 3x squared times v, which is tangent of x. Probably could have gotten away without parentheses there, but of course I have it. Plus v prime, secant squared x, times u, which is negative x cubed. Now, this, especially with those parentheses there, is a perfectly valid way to write this. If I ditched the parentheses, that would get a lot sketchier because it'd look like an x minus x cubed, so I wouldn't write it that way. Honestly, what you would probably normally see is this x cubed out in front of the secant squared. Okay, so you would see it, and then without the 0. So we'd probably have something like negative 3x squared tan x minus, and that minus is just coming from the x cubed secant squared of x. So that's like a cleaned up version of that. Okay. Next one's going to require some quotient rule. So be always on the lookout for those products and quotients, right? This is my u, this is my v. So we need to think about u prime, v prime. Derivative of 1 plus cosine. Well, the 1 we don't really care about. The derivative of cosine is negative sine. And then derivative of secant is secant tangent. Don't forget your x's. Okay. So my derivative, f prime, is u prime times v, which is secant x, minus v prime running out of room, times u, which would be 1 plus cosine x, sorry about that. And all of that would go over secant squared of x. Man, going on to the other line made that look extra messy, but that would be your answer. Okay, so sometimes you're going to need some space for these answers here. Okay, a couple more to do here. Next one, that's going to need a product rule, okay, because I'm seeing a product of two functions, so two things involving x. This is u, and this is v. This derivative, the power, but with not, I'm sorry, the exponential function, but that's not an e at the base, those ones don't show up very often. We did write them down on the previous page, but the derivative of that would just be itself 5 to the x, but times natural log of 5. And then the derivative of 5x, that's just a linear term, so the derivative of that would just be 5. So now we should be able to set up product rule here. So f prime, u prime, so this whole thing, 5 to the x times natural log 5, times v, which is times 5x, plus v prime, which is 5, times u, which is 5 to the x. And that's it. Sorry it kind of blended in with the one up above it, but that's your product rule there. So we've got u prime v, v prime u. Next one, we're going to need a quotient rule. Might want to pause the video and see if you can get ahead of me on this one. This is u, this is v. U prime, v prime. Natural log of x is 1 over x. Sine of x is cosine. Gosh. Brain in my mouth are not connected today. Cosine x. And so we're going to go u prime times v, which is sine, minus v prime times u, which is natural log of x, all over bottom there would be sine squared of x. And again, it's ugly, but it's right. That's the correct answer. Okay, this next one's really weird, and I actually feel like maybe there's a typo in how the problem was written, because usually we take the log of a variable. Usually this would be like log of x. What we wrote down on the previous page is that when your function is log base b of x, the derivative would be 1 over x times log b. I'm sorry, not log b, natural log b. So for this one, the x is really like your 8, and then the a is really like your b. So like I said, the derivative on this one is kind of strange with that 8 there. But we're just going to write it as 1 over the x value, which is 8, and then times natural log of a. It's a weird derivative, but it'll work. It's correct. Now, when we did these examples in class, I asked students which one on this page looked the scariest before we had done any of them. And we've done some really gross ones, right? These product and quotient rule ones, they're kind of a mess. but almost everybody identified this as one of the hardest ones. This is actually one of the easiest, and it's the easiest because these are all adding and subtracting, which means I can just buzz through here and take a derivative of each piece individually. I don't have to do a product or quotient rule. The one thing I would do is rewrite this thing as x to the power of inside over outside, so it'd be 3 over 2, before I try to take a derivative, and I can use the power rule. So my derivative of x to the 3 halves would be 3 halves x, and then 3 halves minus 1 is like 3 over 2 minus 2 over 2, so that'd be a 1/2 power, plus derivative of e to the x, that's one of our favorites, derivative of e to the x is just e to the x, minus, now derivative of cosecant, if you need to go back and look that up, go for it, it is negative cosecant times cotangent. If I'm putting in a negative here and this is already negative, those two negatives can team up and make a positive. Okay, so I just didn't want anyone to be confused about why I'm suddenly putting a plus sign there. So this will be cosecant x, cotangent x. And that's it. This is a really good mixed review. These are the types of problems that we'll be focusing on moving forward. We'll be doing a lot of practice with these, and these are the types of things you'll see on your next quiz. So please let me know in class if you're struggling with anything and if I can help you.